Welcome to the section on decoupling capacitors. Now, first question is probably, what is a capacitor? Now, capacitors are basically tiny batteries which charge really fast and discharge really fast. However, they can't hold the same kind of power that real rechargeable batteries can. And if we ever figured a way to make capacitors hold the kind of capacity that normal electrochemical cells can, it's a whole new ball game. We've got things charging in seconds, cars, whatever. But sadly, we're not there. These particular type of capacitors are electrolytic polarized capacitors, and one side of them has little negative signs drawn on it. So be very, very careful, because just like batteries, they don't like it when you put them in backwards. If you do, in this case, there's a good chance you'll hear a pop or maybe a little bit of flame. You smell some burning. Might have it fly away and spray electrolyte at you, and do not do that on purpose. Anyway, so careful with your capacitors. Put them in correctly, negative side to ground and the other side to plus 5 volts. Capacitors are more or less capacitors, so these aren't special types of capacitors to be decoupling capacitors. That's the purpose that they're there for. So first thing, like before we talk about what decoupling is, I've got to disabuse you of what is probably a misconception you have. If we take a look at this, our power supply, our 5 volts in ground connected to these rails, you might think of it as a perfect constant 5 volts in ground, regardless about what's going on. Whether this potentiometer is drawing more power or less, or if this thing is being sent spikes of power every so often, or turning on and off faster than you can see, that doesn't keep this a nice, constant, smooth 5 volts. And having a nice, constant, smooth 5 volts is very useful for digital circuits, like, say, your Arduino, or maybe something else you have in your circuit. So it'd be kind of nice if any spikes caused by these things turning on and off or changing quickly was smoothed out. Sometimes I think of this as being like a reservoir of water, and you're suddenly like taking water out or shoving it in really quickly, and that creates waves. And we don't want waves in the water, otherwise certain sensitive things might get confused. So to deal with that, we've got decoupling capacitors. They decouple it from the other power supply. So anytime this needs a surge of power, it's got this mini battery right by it, willing and ready to provide it. Or if it goes low for a second, it doesn't require as much power, this will charge up, and that will also keep the levels nice and smooth in our power supply. Same thing with your potentiometer. If someone's turning it really fast and making this, they're making waves in the waters, it'll pull from here first and make it so there's not any waves happening. So these guys are great. They keep our power supply nice and smooth and constant, which is very, very useful if you've got any sensitive electronics that might accidentally trigger and register some pulse to a pin or something like that. Anyway, so that's decoupling capacitors for you. Just capacitors we stick close to devices that might have varying current draws that we want to make sure they don't affect the rest of the circuit. Thanks for listening.